Hi everyone, thanks for joining to this presentation. I'm Nushin Iqbal, I'm a PhD student, and for this project I worked with my supervisor Dr. Paul Wu. I want to present our work on priority-aware folder correction for HTTP. The thing is that when an HTTP client asks for a web page, there is a list of web resources that need to be downloaded. But not all resources are the same. For example, the image files can be rendered incrementally at the client side, so we can use the multi-streaming or multiplexing of Quake to avoid the head-of-line blocking problem at the application layer in the case of packet loss. But for other types of resources like HTML, CSS, and JavaScript, the client needs to complete downloading them before being able to use them. So the multi-streaming is not useful anymore, and in the case of packet loss, the client needs to wait for a function of RTT to receive the retransmission of the lost parts. So we have the idea of using folder correction only for high priority resources to reduce the page load time. And the thing is that HTTP had a complicated dependency tree prioritization scheme that because of its complexity hasn't been used widely. But recently the extensible prioritization scheme was introduced, and this way the client can set the priorities of different resources and the server would know when sending data. So we can use these priority scores for using in our idea of using folder correction only for high priority resources. And also folder correction is not a new topic over Quake. Quake had folder correction initially, but for all data, and because of its overhead, it was dropped. But here the idea is using folder correction only for high priority resources to reduce that overhead. We had some early results over UDP-based data transfer protocol or UDT protocol with two-dimensional XOR-based folder correction for the paper that we submitted to the workshop, but after receiving the positive reviews, we were encouraged to implement this idea over Quake. And among several open source implementation of Quake out there, we have chosen NGTCP2 because it's up to date and it includes the important Quake extensions, especially the extensible prioritization scheme. And also we used OpenFake library for the folder correction implementation part. This open source library was designed and implemented by Vincent Roca team. And it includes the implementation of Solomon and LDPC decoder and encoders. And to further simplify the project, we pre-computed the repair data at the sender side, so the client in the folder correction scenario can ask for redundant data as a web resource to be able to use them for recovering lost quick frames. And we had an emulation testbed using two nodes in EmuLab, and we used NetMTC tool to add delay and packet loss. And here are some early results with Quake. We set RTT to 100 millisecond and we set the packet loss to 10%. And these two diagrams show the arrival order of quick frames at HTTP client without folder correction and with folder correction. As the workload, we had a very simple workload of one high priority file, the green file of size 7.2 kilobytes, the repair file in with folder correction scenario with bind point 8 kilobyte file size that we produced by using Red Salmon, and one low priority incremental file, the pink file of size 26.5 kilobyte. So without forward correction, the client asks for only the high priority and the low priority files, and because of having packet loss, one of the quick frame of the green file got lost. So we need to wait for 103 milliseconds as a function of RTT to receive the retransmission of that lost quick frames, so we could complete downloading the green high priority file at 103 milliseconds, and we could finish the job at 320 milliseconds. But with forward correction, the client asks for the high priority file, the green file, the repair file, and the pink file. And using Red Salmon decoding, we could recover the whole high priority file at 7 milliseconds using two repair quick frames. While if we wanted to wait for the retransmission, we needed to wait until 109 milliseconds, and we could finish the job by 312 milliseconds. So the improvement is 7 milliseconds versus 100 milliseconds to complete downloading the high priority file. As a summary, we talked about using resource prioritization at HTTP server to use forward correction only for higher priority resources, and this way we can reduce page load time. And as a future work, we need to work on improving our implementation over quick, and we need to study the impact of using forward correction on different congestion control algorithms. Thank you very much for joining this talk, and I would be happy to get any questions and suggestions. Thank you.